Welcome to the next lecture module in Organic 2, Organic Chemistry 2, Chem 252. Okay, well, here's the story, folks. Before we start off on this journey together, I have to tell you something. We have looked at the traditional type of carbon all this time. The traditional type of carbon is the carbon that you would maybe look at as your child. And you would say, Carbon, you did an excellent job growing up and starting a family and getting a job and supporting yourself. Good for you. Pat on the back. And all of this is really the background of carbon and the life decisions that carbon has made. So, carbon was born, and carbon chose the correct friends to hang out with through high school and college, graduated with a degree, started a family, bought a house, making some money. But as you can imagine, sometimes these carbons don't quite turn out the way that you want them to. Yeah, that's a problem for us. Sometimes these carbons are going to be born, and they choose to hang out with the wrong crowd. And before you know it, they're out in the streets, and they're busting out windows and setting buildings on fire. They're stealing and robbing people, hot wiring cars in the parking lot and driving off with them just to sell them to make some money. Nobody wants carbons like that, but it's a life choice. These carbons have made the life choice to do the life that they were doing. And part of this is who carbon hangs out with. Yeah, that's right. It's all about persuasion. So I can take a person in high school and I can put them into a group of people that all have a certain ideology. Right? They think the same way. They have certain goals in life. Maybe they're high academic achievers. And that carbon will typically mold itself under peer pressure and what its friends are doing to become somewhat of the same thing, cut from the same cloth. Or I can take a carbon, a student, and I can put them into a crowd of people that's very rebellious. Like, power to the people! We're going to burn everything down! And that carbon will typically mold itself with that way as well. It's all about who you hang out with, folks. That's what this boils down to. And carbon hangs out with a different group of people sometimes. And this is going to start the world of organometallic compounds. And here's the key word. That key word is metallic. Up until this point, what we have seen is a traditional type of carbon on both sides, right? And this carbon has some type of group. Let's say an OH group. What have we done? What have we done this entire time? We've looked at carbon and we've looked at oxygen. And just like in Chemistry 251, Orgo 1, the same story existed. Okay, well, carbon's got these electron pairs, and oxygen is an electron-greedy sucker. And it sucks the electrons toward it. And because of that, we end up with a partial positive carbon and a partial negative oxygen. And every single time, we have talked about a carbocation. Right? A carbocation gets formed. A carbocation is on a primary, carbocation on a secondary, carbocation on a tertiary. That has been our narrative for weeks and weeks. And it will be the majority of the narrative this semester, except for this particular lecture. And the reason is because the carbon is hanging out with a different group of people. Maybe with the wrong crowd. Or the right crowd, depending on what you like to do. But this carbon and this oxygen share a bond, and this bond is slightly polar, and the reason is because oxygen is more electronegative than the carbon, and it's more of an electron-greedy atom, and that's what electronegativity is all about. So it rips and it sucks all the electrons away from poor little carbon, and it can't defend itself, and that carbon becomes positive because of that. But what if we could get carbon to share a bond with a different buddy that has a different view in life? A bond with a buddy that is less electronegative. Oh, that's where this lecture's headed. It's a complete flip of everything that we have discussed in Orgo 1, and really, for the most part, the alcohol lectures as well, since we've made it through that section. So if carbon has a greater electronegativity value, then that carbon becomes the electron sucker of the bunch. Oh, and this makes carbon feel so good. You know, all this time, carbon's been in these relationships down here in the very bottom, and these relationships have not been very good for carbon. Those relationships, that person that carbon has dated, oh, it's just wanted and wanted and wanted and wanted. And now for a change, for just a slight change, carbon is in a relationship where it can now be the taker and the wanter. Carbon is now finding himself or herself in a position where it can become the electron sucker of the bond. So what does that do? Well, if that's the relationship that happens here, and carbon has a higher electronegativity value, carbon becomes the electron sucker, and what we would see is a partial negative on the carbon and the partial positive on this other group, whatever that group might be. That's the buddy that carbon's hanging out with now. Well, this is not a carbocation anymore. This is now labeled as a carboanion. And that we talked about in Organic 1. So here we see a dynamic shift. And everything that we've talked about will be flipped because of it. And the reason is because everything that we have done has relied on a carbocation. But now our discussion is going to focus on a carboanion instead. That is the concept of organometallics. So what are these questionable groups, questionable friends that carbon begins to hang out with to make this dynamic change? Well, okay, first it has to have a lower electronegativity value. Okay, well, where are those lower electronegativity values? Well, here's a part of a periodic chart. And what we're focused on right now is this carbon, 2.5. Now look at this here. Up until this point, just in the last lecture, what did we talk about? Oxygens, right there they are, 3.5 electronegativity higher. That's why alcohols reacted the way that alcohols did. What are some of the other groups that we've talked about? Well, we've talked about double bonds, we've talked about triple bonds, but in substitution and elimination, we've also talked about the halogens, right? Fluorine and chlorine and bromine and iodine. Look at this. The majority of those halogens have an electronegativity value greater than carbon. Now, iodine had an EN of 2.5. And that EN of 2.5 is very close to that carbon's 2.5. I mean, here on this chart, they're identical. But you know what we said about iodine, haven't you? Oh, we don't really like to use it because the reactions are not as great, or iodine's too big and fat. It's not going to want to go onto a molecule. It's going to be a little bit more stubborn. Okay, well, this is one of the reasons. The electronegativity is about the same as carbon. That's why it's not a very good choice. But folks, some of the other groups that we've talked about too have been amine groups, 3.0, sulfur, which we know thiol groups, 2.5. So this is the part of the periodic table that we have been focused on this entire time. And now we're going to flip the script. We're going to go in and we're going to talk about organometallics. We need to choose things that have lower electronegativity values than carbon in order for this to work. So right there's carbon. And we know the periodic trend from Orgo 1 in general chemistry is that electronegativity value decreases as we go across to the left, and it typically decreases as we go down the chart. I mean, look at this trend. Fluorine 4, chlorine 3, bromine 2.8, iodine 2.5, lower, 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 lower. Now, it doesn't happen this way every single time, but it's a general statement that we can use. If we go to the left, starting from fluorine, look at what happens to the EN value. 4, 3.5, 3, 2.5, 2, 1.5, 1. It gets lower, 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 lower. This is why organometallics work the way that they do. Because in the valley of the periodic chart, now remember this is just part of a chart, in the valley, this is where our transition metals, ding, 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 are going to be located. Well, if this lecture is about organometallics, then we're probably using metals, and metals are going to be found in the transition valley. So we're going to be looking at things that maybe have something like copper in the reaction now. That we've not seen before. We're going to be looking at things that maybe have palladium in it or cadmium in it. Those we've not seen before. We're going to be looking at things over in the first two groups. Why group 1 and group 2? Because these are also metals. I mean, think about what you named these in general chemistry as. This very first group that goes down, this was called the alkali metals. And the second group was called the alkaline earth metals. Those are metals as well. That's why we named them metals. So transition valley elements and the first two groups, look at this. The majority of these have lower electronegativity differences than carbon. Because of that, carbon really likes that feeling. Carbon now can be the electron sucker of the bunch. Carbon can now share a bond with a metal, and carbon can feel a little bit more powerful because it's the needy one. And for a change, carbon says, I'm going to get what I want in this relationship, and I don't care what you think. I am tired of being taken advantage of. So I'm going to take advantage of somebody else. I don't know if that's a very good attitude to have in life, but that's what carbon's going to be doing in organometallic reactions. This is where your head needs to be, folks, right here. This is why we have a whole lecture on organometallic compounds. And it goes back to the basics. It goes back to the basics of electronegativity values, what electronegativity really means, and the proper definition and how it affects a bond between the two atoms that share it. So in a way, nothing really is changing. All of our definitions are staying the same. We're just pairing this carbon up with a different type of atom for a change. And because of that alone, it flips the script. I'm now dealing with negative carbons, not positive ones, and it will behave differently. Now, what are some of these other metals that we might see in this lecture? We're not going to talk about all the metals, of course. I mean, good gosh, we'll be here forever. But this is why organometallics could be a completely different course at another institution. This is not uncommon. There's so many different choices and there's so many things that happen. And it's really a different type of field of organic that we can make it a standalone course if we want to. But the ones that we're going to see most of as far as organometallic goes, right here. Here's the list. Magnesium, lithium, copper, cadmium, palladium, zinc, aluminum, lead, and mercury. Now, this is just the skim off the top, folks. And we're going to be seeing reactions in this lecture module that will focus on a metal and the properties that that metal brings to the table and the reactions that that metal will allow based on its valence shells and electrons that it brings to the table and the location on the periodic chart and the electronegativity values and how it reacts with even the solvent. All of these things are very, very important in the world of organometallic reactions. So this is going to prep you a little bit for what we are getting ready to see. And I hope it puts your mind in a different spot, because that's the most shocking thing about this lecture series. This lecture series is all about negative carbons, not positive. And we're so used of working with those positive carbons that when we see the negatives and we start explaining reactions in a different way, you're being like, whoa, now wait a minute here. I thought you told me weeks ago that this is what happened. Or I thought in Organic 1, this is what you taught me. It does. It does. It still happens that way. But you're forgetting that we're working with negatives and not positives in this lecture. So sit back, enjoy the show. Some people love it a little bit better. Some people think that this is a little simpler. I don't know. It's just a different point of perspective. I guess it's just really going to boil down to which group you like to hang out with a little bit better. And I'll see you in the next video.